In this video, we're going to learn how to divide complex numbers. So I'm going to start off with a statement that number pairs of the form a plus bi and a minus bi are complex conjugates. So the fact that we just add one and subtract the other already makes them conjugates, but now since they're dealing with complex numbers, we call those complex conjugates. Now, I want to talk about the product of complex conjugates. Now, in the last lesson, we saw two conjugates be multiplied together and it became real number. So let's see what happens when we take a very general complex conjugates and see what happens when we multiply them. So here, I'm going to distribute this into that parentheses. So I'll have A equals A times A plus BI minus BI times A plus BI. So when I multiply this out, I will get A squared plus ABI and then minus ABI, A times B times I, and then minus B times I squared. Now I know that's B squared times I squared, but I do want to show a nice pattern that emerges first. So here I can see that my middle terms are opposites. That usually happens with conjugates. And I'll be left with A squared minus BI squared. Now, the reason why I wrote it like this, because this is difference of squares, which is usually would factor into A plus BI, A minus BI, whatever the square root of those two numbers were. So I just want to show you that this is very similar to difference of squares. Now if I finish this off, I'll get A squared minus B squared I squared. Now I squared is equal to -1. So now instead of minus B squared, it becomes plus B squared because that's times -1. So we just end up getting A squared plus B squared, which has no I in sight. So meaning when I multiply by a complex conjugate, I'll end up having no imaginary number whatsoever. This is actually very important when it comes to dividing. Because in order to get a answer, a complex number from multiplying, adding, subtracting, or dividing, it needs to be in this form A plus BI. We have a real part and an imaginary part, but when we're dividing, we have an I in the denominator. So the trick is actually to multiply the denominator by its complex conjugates. So meaning 3i is the same as like 0 plus 3i. So I'm going to multiply by its conjugate 0 minus 3i, or just -3i. By doing so, I can turn that denominator into a real number, and then I'll be able to rewrite this expression as a complex number, just a single complex number. So if I were to do this, up top I have -3i times 9, which is -27i, and -3i times 12i is minus 36i squared. And then in the denominator, I'll just have 3i times negative 3i, which is negative 9i squared. And again, I squared is equal to negative 1. So what I can do is just replace all my I squareds with negative 1. Give me negative 27i plus 36, because I squared times negative 36 over a positive 9. And now both of the numerators are just being divided by one real number. So now I'll do my real part first, which is this 36. So 36 divided by 9 is 4. And negative 27i divided by 9 is minus 3i. So there is my division of these two complex numbers, gives me 4 minus 3i. Now let's see this in action again. So we have 2 plus 3i over 1 minus 4i. So now I'm going to multiply 1 minus 4i by its complex conjugate, 1 plus 4i. Just change that sign in between. But whatever you do to the bottom of a fraction, you need to do to your numerator as well. And when I multiply these out, in my numerator, I'll get 2, which would be 2 times 1, plus 2 times 4i, which is 8i, 3i times 1, so plus 3i, and then plus 12i squared for 3i times 4i. Then in my denominator, I'll have 1 times 1, which is 1, 1 times 4i, which is positive 4i, and again, I'm just distributing. Negative 4i times 1 is negative 4i, and then negative 4i times positive 4i is negative 16i squared, and now I need to simplify. My 4i's will cancel, and my I squareds are equal to negative 1. So I'm going to replace all of them with negative 1. Give me 2 plus 8i plus 3i minus 12 all over 1 plus 16. And now I'll combine all of my like terms. So 2 minus 12 is negative 10, put in the real part first, plus 11i all over 17. And again, I want to have a clear real part and a clear imaginary part. So my final answer will be negative 10 over 17 plus 11 over 17i. So real part, imaginary part. That is the division of those two complex numbers, is this complex number. Now I want to show you another way to go about dividing, because now we know that complex conjugates just give me a real number. We can actually use that to our advantage to make this process go by just a little bit quicker. So now look at my denominator. I want to get rid of I down here. So I'm going to use the conjugate of the denominator and multiply that to the numerator as well. But now instead of going out the long-winded process of distributing, I'll still have to do it for my numerator, but my denominator, I know it's just going to be a squared plus b squared. So 3 squared would be 9 plus 4 squared, which is 16. If I multiplied it all out, that's what I would get. So it's really convenient. Now my numerator, I still have to distribute. So 5 times 3 is 15. 5 times negative 4i is negative 20i. Negative 2 times 3 is negative 6i. Then negative 2i times negative 4i is plus 8i squared. Change my I squareds to negative 1 and combine like terms. So 15 minus 20i minus 6i minus 8 all over 9 plus 16. Then simplifies to 7 minus 26i all over 25. Which for my final answer will give me 7/25 as my real part, minus 26/25 I for my imaginary part. So definitely not too long of a problem. You just have to be able to distribute your numerator once you realize that. Now, for this next problem, I have a 1 plus I squared in my denominator. I need to simplify this just so it's a simple complex number with a real and imaginary part. Right now, it's a binomial squared, so I'm going to need to simplify that. So 1 plus I squared is the same as 1 plus I times 1 plus I, which is a binomial squared. So give me 1 times 1, which is 1. And then using the outer terms gives me I plus I. So plus 2I. And then plus I squared for I times I. I squared is negative 1. So I get 1 plus 2I minus 1. The 1's will cancel, and I'm just left with 2I. So 1 plus I squared is equal to 2I. So for this problem, I'm going to be dividing 3 plus 2I over 2I. Again, I'm going to multiply by its complex, the denominator's complex conjugate to get rid of the I down there. So I'll multiply by negative 2I into my numerator and my denominator. And then my numerator becomes negative 6I minus 4I squared, all over negative 4I squared. I squared is negative 1, giving me negative 6I plus 4 all over 4. And now I do my real part first. 4 over 4 is 1. And then 6 over 4 is negative 3 halves, so minus 3 halves I. And that is how you divide complex numbers.